Good, fantastic. So, can I give you 3 minutes? What do these words mean to you? What do these words mean to you? So, independent, dependent, and mutually exclusive. Can you discuss them on your tables for me? All right, okay. So, what do we think independent means? What do we think independent means?
One won't affect it by another.
Sorry?
One won't affect it by another.
Yeah, absolutely. So if one thing happens, it's not going to affect another thing happening. Okay? So if you're independent, the two things are unrelated to each other. Yeah? Or more sort of saying that if one thing happens, it's not going to affect the probability of another thing happening. Okay? So how could we write that using conditional probability? Well, if we have two events, A and B, okay, if you say the probability of A happening, given that B has already happened, okay, if they're independent, what should this be equal to? So B has already happened, and you've got the probability of A. What should this be equal to if the two events are independent of each other?
B didn't happen.
Exactly. Okay, so in other words, if probability of A happening, B not happening, okay? So the probability of A happening given that B has already happened should be exactly the same as the probability of A happening given that B has not already happened. Because it doesn't matter whether B has happened or not. If they're independent, the probability of A should remain the same. That make sense? Okay, good. What about dependent? Oh, by the way, can you give me an example of an independent event? Or two independent events? Can you give me an example of two independent events? Just two things that are completely unrelated to each other. So if one thing happens, it doesn't affect the other. Well, an example which I've come up with is the probability of it raining and the probability of the day of the week. Yeah? Those two events are independent of each other. Doesn't matter what, so if it rains, it doesn't depend on what day of the week it is. So for example, it doesn't always rain on Wednesdays. Yeah? Because it just rains whenever it wants to. It doesn't matter what day of the week it is. That make sense? Okay, good. All right, so what's dependent then? Yeah, absolutely. So this is introducing this idea of conditional probability, right? So the chance of one event happening does depend on whether the other thing has happened or not, okay? So it's the idea of conditional probability. Conditional probability, okay? So in other words, another way of saying dependent is that the probability of A given B should not be the same as the probability of A given not B. By the way, that dash means not B. Okay, B has not happened. Okay. So in other words, if these two things are not equal to each other, it means that they must be dependent on each other. Okay. So it's this idea of conditional probability. Conditional probability. Is that okay? Okay, fine. Did anybody come up with an example for dependent events?
Food and weight.
Sorry?
Food and weight.
Yep, food and weight, right? So the more food you eat, so the chance of you being slightly larger. Yeah, weight, right? Good. What did I come up with? Wearing a coat and snowing. Those are probably two dependent events, yeah? If it's snowing, that increases the chance of you wearing a coat. Yep. Okay, good. Did anybody come up with a definition of mutually exclusive? I think this is the hardest one on there. Sorry? Absolutely right. So it's two things cannot happen at the same time. Okay? The clue is kind of in the name. If you're mutual, what does mutual mean? Means together, right? Means together. So like you're mutual friends, it means you're friends like together, right? Exclusive? It's not happened anywhere before, yeah? So think about it, if you look on like a newspaper, it'd be like world exclusive. It means it's not happened before, okay? So mutually exclusive simply means that the two events cannot happen at the same time, okay? So in other words, if one thing happens, the other thing cannot happen, yeah? So look at this notation here. The probability of A and B. Okay, so here's my two mutually exclusive events, event A and event B. Okay, In other words, the probability of event A happening and event B happening should be equal to what? 0. They can't happen together, so therefore the probability has to be 0. They can't both happen. Okay? Now I've introduced some new notation here, which I think will be worthwhile looking at. If you look, a simpler way to write and is with this symbol here. Okay, this symbol here. If you're used to set notation, so let's say two events, A and B, okay? Does anybody know what that symbol means? It's the middle bit, yeah, it means intersect. So where do the two sets intersect, okay? Because that's the events which happen in both A and in event B, okay? Does anybody know what this thing means?
It means all, both circles.
Yeah, so in other words, probability of A or B. Yeah, so that's an and, that's an or. In other words, it's everything. Oh, it's everything, yeah? So everything there. Okay, both circles. Yeah? So anything in A or anything in B. So just be aware of this notation because it is handy. Okay? So that symbol simply means intersect or and. So you want things in that set and in that set. That thing means the union or. Okay? So just be aware of that. Just be aware of that. Okay? Good, fantastic. So can anybody come up with an example of two events that are mutually exclusive?
You can't get heads and tails at the same time.
Absolutely. You flip a coin, you can't get both heads and tails. Yeah? The example I gave, you can't turn left and right at the same time. Yeah, you can turn left or right, but you can't turn both. That make sense?